Welcome to the Paleontology Department at the Chicago Field Museum. I'm Sammy Clute, and today we're discussing the classification of living fossils, a term used to describe organisms that look virtually the same today as they did in the past. And we're talking a long time here. Take a look at this coelacanth. This coelacanth looked virtually the same today as it did over 400 million years ago, during a geologic time period called the Devonian. Since that time, there have been over 4 major extinction events, one of which wiped out more than 95% of diversity on Earth. Scientists have been studying living fossils like the coelacanth, trying to understand the concept of evolutionary stasis. How have these organisms persisted for so long without changing in these diverse ecological environments? The term living fossil is usually applied to a species or a group of species like a genus, but there may be other species or genera that are also quite old that have not been called a living fossil. So this investigation is asking, a living fossil compared to what? In recent years, more and more papers have been published claiming that such and such organism should be called a living fossil. Look, see, it's really old. But many of these papers don't even explain the evolutionary history of other organisms closely related to the living fossil. Is this extreme longevity even unusual? To answer this question, we've focused on 2 commonly cited criteria of living fossil status. 1, their geologic range, which means we look at the oldest fossil that we've ever found of the organism and the newest fossil that we've ever found of the organism and see how long it's really been around. And 2, we're also looking at a reduction in biodiversity, so we're looking to see if there are more genera alive in the past than there are today. This summer, we've conducted a pilot study looking at 8 different canonical living fossils: the coelacanth, the Amani rabbit, ginkgo trees, crocodiles, the metasequoia, tuataras, hula-painted frogs, and the platypus. We looked at the fossil records of these groups to see how their geologic range compared to their close relatives in their taxon. In order to look at these records, we first have to establish what is closely related. For that, we use this handy website called the Catalog of Life. This website has a detailed phylogenetic tree of pretty much everything that's alive today. After we know what closely related organisms are around today, we need to know what their relative geologic ranges look like. To the paleobiology database. This website is where we found most of the information we need to evaluate these living fossil criteria. You can search any species, genus, or family name, and out will pop the entire fossil record for that group. That means if we're looking for the fossil record of the tuatara, we can type in Sphenodon, which is the scientific name of their genus, and out pops every fossilized tuatara ever found. From there, we can generate graphs like these, comparing the geologic ranges of tuataras to other groups of similar lizards, even those that have already gone extinct. We can also look at the trajectory of biodiversity over time. Is the tuatara a true relic of its past, or are there more varieties of tuataras alive today? In doing this work, it's become apparent that there are some examples of canonical living fossils that might not really be the oldest of the old. For example, these graphs show that the metasequoia is not a relic of its family. In fact, there are more genera alive today than there ever have been before. It's also not the oldest genus in the family. There are 5 genera that are still alive today that have longer fossil records than the metasequoia. These results indicate the need for further investigation. There are hundreds of more species that have been called a living fossil, and right now, the meaningfulness of that term is relatively unclear. I will be continuing this research back at Whitman. Hopefully, we will resolve a better understanding of what being a living fossil really means, and scientists will be able to use this term more meaningfully in their investigations of evolutionary stasis. Thanks for watching.